We will all fascinated when we hear the word aliens or extraterrestrial life. The detection of life outside of Earth has always been one of our primary quests in astronomy or science in general. While the idea of life out there has been bugging scientists for quite some time, some people have introduced a lot of unscientific, pseudoscientific elements into it, like conspiracy theory, unscientific claims, etc. These elements were never a part of science. We have a more formal discipline of a study concerning extraterrestrial life known as astrobiology or exobiology. So we're gonna see a definition of astrobiology. To give a brief, astrobiology is an interdisciplinary field that concerns itself with a study of life in the universe. It attempts to explain origins, evolutions, distributions, and future of life in the universe. One of the primary questions that astrobiology seeks to solve is that whether extraterrestrial life actually exists, and if it does, then what could be the methods through which could detect it. Astrobiology is an overlap of biology and astronomy. Astrobiology takes help of numerous scientific disciplines such as molecular biology, biophysics, biochemistry, chemistry, astronomy, cosmology, geology, etc. Astrobiology also includes the study of patterns of chemical evolutions of ancestors of life in the interstellar medium and on the planets and small bodies of our solar system. Astrobiology and abiogenesis. Astrobiology also consists of studying the life on Earth back to very start, that is abiogenesis. As we know that mechanisms involving abiogenesis are not understood very well. And much of the propositions of this mechanism are still in stage of hypothesis. We aim to get a clear understanding of abiogenesis through astrobiology. We can develop or more general guidelines of how abiogenesis occurs through astrobiology. As the origin of life, as we have studied, is very specific to the environment of ancient Earth. We should not expect life to arise the same way on the other celestial bodies as it did on Earth. When we are studying about the course of life in the universe, we need to know about the origin of planetary system, as we need to peep into their habitable zones. We need insight into origin of organic compounds in space. Yes, we have detected some. It's where astrochemistry comes into play. Research on biosignatures for the detection of life. In 1961, Frank Drake proposed the following equation to try to estimate the number of civilizations and capable of making radio communications in our galaxy, where n is equal to number of civilizations in the galaxy that emits radio signals. R star is equal to rate of star formation. F is equal to fraction of them with planetary system. N is equal to number of habitable planets in each planetary system. Fl is equal to fraction of them that have developed life. Fi is equal to fraction of them that have developed intelligent life. F is equal to fraction of civilizations that perform interstellar communication. And L is equal to length of time that these civilizations release detectable signals into space. The famous Drake equation may look a little vague, as we have not even discovered microbial life yet. But it's very important in the field of astrobiology. It formed the backbone of astrobiology. As a science, it must be noted that the usefulness of the Drake equation is not in the solving, but rather in the observation of all the various concepts which scientists must include when considering the question of life elsewhere, and gives the question of life a basis for scientific analysis. The equation has helped draw attention to some particular scientific problems related to life in the universe, such as abiogenesis, the development of multicellular life, and the development of intelligence. Drake equation is of seminal importance because it's a roadmap of what we need to learn in order to solve the fundamental question of life. Let's talk a little about element of astrobiology. Astrogeology. This field is concerned with the geology of the solid bodies in space, such as the asteroids and the planets and their moons. The information collected from astrogeology helps measure a planet's or satellite's ability to develop and sustain life. Astrochemistry. It is the study of abundance of molecules and their reactions in the universe. Astrochemistry explains how molecular evolution occurred with various extreme astrochemical environments, such as interstellar medium, the molecular clouds, the star-forming regions, and the planetary body. They examine the exotic chemistry occurring in the atmospheres and on the spheres of planets, satellites, and other solar system bodies. Some examples like comets and meteorites that may nurture prebiotic molecules. Astrochemists study and detect organic molecules relevant to biology in space and explore their implication for life on other planets. Cosmology. The establishment of cosmology as a science provided a parallel to the building up of the scientific status of astrobiology. Prior to the discovery of expansion of the universe, there was little that cosmology could contribute to the questions of extraterrestrial life, aside from probabilities. After our discovery of the expansion and evolution of the universe, the situations changed significantly. The entire cosmos was recognized as undergoing steady change. The history of the universe took on the complexion of unfolding in many stages, with the formations of first atom and molecules, then galaxies and stars, and most recently planets and life. The most important and simplest feature of the overall change in the universe that the expansion produces is the rate at which it occurs. There are many other fields which astrobiology takes help from. I could obviously not include all of them in one single presentation. Also, I did not include biology and astronomy as I assume that you possess a basic understanding of them. While this overview of astrobiology looks all good and it seems like there is ample of life in the universe, I would like to remind you of the fact that to date we have not detected any life biosignatures beyond Earth. Now, there could be a ton of regions that we have not detected life, and this is an area where conspiracy began to flood. The Fermi Paradox. The Fermi Paradox highlights the apparent contradiction between the lack of evidence for extraterrestrial civilizations and various high estimates for their probability, such as the Drake equation. Some of the points that highlights the apparent contradiction are: there are billions of stars in the Milky Way similar to the Sun. With high probability, some of these stars have Earth-like planets. Many of these stars, and hence their planets, are much older than the Sun. If the Earth is typical, some may have developed intelligent life long ago. Some of these civilizations may have developed interstellar travel, a step humans are investigating now. Even at the slow pace of currently envisioned interstellar travel, the Milky Way galaxy could be completely traversed in a few million years. And since many of these stars, similar to the Sun, are billions of years older, the Earth should have already been visited by extraterrestrial civilizations, or at least their probes. However, there is no convincing evidence that this has happened. There are many proposed solutions to the Fermi Paradox, which I may cover in future posts as we might delve further into astrobiology. So guys, we come to end with this. Hope you liked this small presentation of ours. Also, please note that astrobiology is immensely complex and wide field, and it is almost impossible to cover all of the contents into a single presentation. Though, we hope you would have got a rough idea. Thank you.